Simulations are an incredibly powerful tool for calculating probabilities, and they're used a lot when the probabilities are either too tedious or time consuming or difficult to find by hand. There's You see them everywhere in statistics, especially because nowadays you can just have a computer calculate it for you and give you the answer without having to design it and take the time to do it yourself. Technology makes doing simulations so easy. When I was working on my master's in statistics, my big end of master's project that I was doing, I had to calculate a bunch of probabilities and figure out the theoretical side of things. But then to make sure I had actually done my work correctly, I ran it through a computer simulation. So they have all sorts of uses, and they're really, really valuable in the concepts in the realm of statistics and in probability. So, what actually is a simulation? Good definition of a simulation is an imitation of a chance process used to estimate a probability. Essentially, you try to recreate whatever it is you're studying and use your recreated model to figure out the probability where it would be like either impractical or tedious or impossible to do it in real life. We've done several examples of simulations already in this class, and we'll do a lot more before the end of the year. On the very first day of school, we did that pilot discrimination example. That was an example of a simulation. I didn't bring 15 pilots into our classroom and start picking them. I used like a little bag with the colored cubes in it, and we've estimated probability that way. So you can use some other sort of object to represent your situation where it's easier to handle. You can also use a computer or technology. Just in our last lesson, we did that thing with the textbook slash baby thing from 5.1a. That was a simulation. And we've done others over the course of this semester already as well. Very common concepts. So let's talk about how you actually go about designing a simulation yourself. In real life, you're going to use technology. Computer's probably just going to do it for you. But even though that's true, you need to have an appreciation for what it is the computer is doing. I understand how to, like, a simulation may work, even though I don't want to do it myself. I can at least use that information to help me when it gives me my results. You want to be able to appreciate what is going on behind the scenes. So AP Statistics makes you guys design nice basic simulations or do small scale ones by hand to give you an idea of how they work, even though in real life you would probably just use a computer and do 100,000 trials. So the four-step process that you'll use for this kind of problem is a four-step process I've referenced before. It's our books thing, and we do it second semester too. But the four steps are state, plan, do, and conclude. And it talks about what each of these steps are going to be. Basically, you set up your problem, you plan out how one trial is going to work in lots of detail. Then you do it a lot of times, and you estimate the probability. So we'll walk through an example, and you guys will see how that works. But this, basically, when you write these out, you're going to have to give lots and lots of very specific detail so they know that you really understand what's going on. So first thing we're going to do is look at the textbook example that we did just last time. I think with this one, well, we'll talk through it, and then I'll just have the answer flash up there so you guys can see what's going on. First thing you would do is state what probability you're trying to find. Kind of set the stage. So I would talk about, for our textbook problem, what's the probability that if you have 4 people who all randomly shuffle their textbooks and grab one, that none of them get their same textbook back? You're basically just setting the stage for your problem. Then in the plan step, what you would do is you would talk in a lot of detail about how you're going to work your simulation. How does a trial work? It could be where we do something with random numbers. We use like randint on our calculator. We could use a random table. We could actually put index cards and deal them out, and that might not be a bad way to do it. So I think for this one, what I'm going to say and what I'll end up writing about in a second is I'm going to have 4 pieces of paper. 1, 2, 3, 4. And then what I'm going to do is I'm going to have 4 smaller index cards, also numbered 1, 2, 3, 4. My 4 pieces of paper will be out. What I'm going to do is I'm going to shuffle those 4 index cards up, little index cards, and deal them face down on each piece of paper. And I'm going to see if any of them matched. So I do a trial where I dish out a card to all 4. I see if any of them matched. And if they do or they don't, I keep track of that. So I write down if there were 0 matches or if there was something else going on. Okay, that would be like one trial. And then I would do that same thing lots of times, over and over, deal out 4, deal out 4, deal out 4. And after I do it like 100, 1,000, 10,000 times, I would look at what proportion of the time I got 0 matches. So I take the number of zeros out of the total number of trials. And that's basically how that would work. So I'll put up an answer that gives sufficient detail for my explanation right there. You very easily could have done this a different way with like randint or something like that, and that's totally fine. But I'll do the index card way when I write this one up. All right, so you can see below, it's kind of a lot that you have to write out for one of these. People don't usually enjoy doing simulation style questions. Thinking about them isn't so bad, but writing them out is a little bit tedious. But in the blue, I have my original question. Purple here is talking in detail about how one trial would work. The orange is really easy. You just say you repeat many times. And then in theory, you would actually do some trials. I just remembered from our last video that they probably was around 38. So I made this up. I didn't do 100 trials myself. In like practice, like for a quiz or something, you would probably do something like 5 trials or 10 trials, and it'll tell you how many to do. We'll get practice with that towards the end of this video, but you just do your process and then you estimate the probability that they were looking for. And that's how you set up a simulation. So this one, I think, wasn't that bad to write out. Like you can kind of just logic it and be like, okay, yeah, 4 people, 4 books, and then you can make something that works pretty well. But naturally, probability can be tougher to wrap your head around depending on how complicated the situation is that you're talking about. So we have a brand new problem right here. There's a basketball player, and apparently that player is considered very streaky by the announcer. They justify saying that they're streaky by saying, wow, they make a lot of their shots in a row. And in this most recent game, the player took 30 shots and had a streak of 7 in a row where they made them. Okay. So with sports examples in general, you have to make an assumption that's maybe or maybe not realistic, which is that like one shot is independent of next. So if you airball on your first shot, that's not going to get in your head and influence how you do on your next shot. Each shot is considered independent. That may or may not be realistic for certain players, but it's usually considered an okay assumption to make. So basically, this announcer is saying this guy is a streaky shooter because in 30 shots, he got 7 in a row. And that seems like a lot. That seems like a big deal, getting 7 in a row. The player makes 47% of their shots overall, but that's not why they're saying the person is streaky. They're streaky because they made 7 out of a set of 30. So we want to figure out, is that a big deal? Could you be a 47% shooter and get 7 in a row in a set of 30 pretty easily? Or is that kind of hard to do? So we have to think and wrap our head around how we would recreate this tougher situation with a simulation. So maybe even pause me. It'd be good if you did to think about like what you would do, and I'll give you some thoughts or ideas on this. So the first thing is that you need to have 30 trials in whatever you're doing. So if you're using randint, if you're going to like do, I don't know, something with a coin or whatever, or a die, you need to roll 30 times for one trial. So you have to have 30 shots represented just for one trial. And then we would do that a bunch of times. If you said something like flip a coin, see if it's heads or tails for making a shot, that wouldn't work out because they're a 47% shooter. If they were a 50% shooter, that'd be perfect. We could just very easily flip quarters and look at like how many heads in a row we got. But because this probability is a little bit more off the wall, the best thing to do here is to use some sort of random number generator and do it that way instead. It's going to make it so you can actually get that 47% that you need. So again, what I'm going to do here is talk you through what I would do. And then after that, I'll write up a nicer explanation for you guys to copy down so you can see what a full credit answer would look like. For this problem, I want to do randint on the calculator. And when you do randint, your digits don't need to be the same size. So I'm going to go randint, and I'm going to do 1 through 100 right here. I'm basically trying to recreate a 47% shooter. So what I would do if I do a random 1 through 100 is I would look, and let's say the numbers 1 through 47 means that you made the shot. So I'll put yes for that. And then I would have 48 all the way up to 100, meaning that they missed the shots. Okay. Now, do you have to have the labels the same as me? No. If you did 1 through 53 miss and then the rest of them make, that's fine too, as long as it appropriately represents the problem. So what I would need to do now, once I have these labels right here, is I would hit randint, and I would do that 30 times. Oh, I got 30. I got 37 for my first number. That's a make. Oh, I got 42. That's a make. Oh, I got 74. That's a miss. Oh, I got a 91. Miss, etc. And you would do that until you have 30 trials altogether. So you would do that for all 30 of these. After you get your 30, actually, before I get to that, let's think really quick about whether repeats would be okay. Do we want repeated numbers to be allowed? So like if I get the number 1 for my first trial, could I get the number 1 again? The answer is yes. I would want to be able to repeat a number because these aren't actual like objects that I'm sampling. These are meant to represent probability. And if I take out the number 1, well, then it's not a 47% chance I'll make it anymore. You're messing with the probabilities. So you would want to allow repeats, and I'll talk about that when I write my answer. So anyway, you get your 30 trials right here. A lot of times we do this in class with randint, and then we go around the room because everybody has a different trial. After you do this, though, what you care about is not how many you made. We just want to see how likely it is that you get 7 in a row. That's the probability that we cared about. So I would look through all my yeses and nos right here and see if I got 7 yeses in a row at some point in my process. If I did, then that's a success for my trial. I got it 7 in a row. And if I didn't, it would be a no. After you do that a bunch of times, you would just count the proportion or find the proportion of times you got 7 or more, and then you would calculate a probability. So I will write up a little explanation of what that looks like. Okay, so here is a long kind of written out answer here that would get full credit for a problem like this. Again, I know it's not fun to write this down, and it's like these problems take a little bit of time to write them out, but you have to be very, very specific in what you say. I basically recapped everything we talked about right here, and I made sure I mentioned that repeats were okay for this problem. And then I just made up a probability. Usually when I do this in class, we get something pretty low, like nobody or one person gets 7 or more in a row. So I said out of 20 people in class, because like what we would have done is had each of us do it, and then we'd get our trials that way. Because it takes a long time to do 30 numbers, and that's just for one trial. So yeah, you would get a probability, and it would be fine. So simulations, the trick is mostly just wrapping your head around how to design the problem and then taking the time to actually write the thing out. We're going to talk about one more example in this video, and we're going to do it with a random number table. Which we've used before back in our first chapter when we talked about chapter 4, when we were talking about like random assignment and that sort of thing. When you use a table, you need to make sure, green doesn't show up very well. Let me change colors here. So make sure all labels are the same size. So we've talked about, like, if we were doing that same problem we just did, we could go 0, 1 to, I guess if we did 0, 1, oh, that'd be weird. I'd have to go 0, 0, 1 to 100, or I can go 0, 0, 0 to 0, 9, 9. Either of these would have been okay. Since I had 100 numbers, I need 3 digits apiece that I would look at. And also talk about rejected numbers. So you got to talk about any numbers you're not going to use, and we'll see how that plays out in our next example. So those are just 2 things to watch out for here. This one, I want to do a shorthand for, so I'm not going to make you write the whole thing again. Hopefully you wrote the last 2 out. We'll just talk like highlights and actually work out the simulation on the table on the next page. So I want a sample of size 6, and I have 60 seniors and I have 30 juniors. So I put everybody's name on a paper, I put it in a bag, and I pull them out. But somebody pointed out, well, you should do a stratified sample instead and make it representative to the population weights, because I have I've double the seniors that I do juniors. but I just shuffled all the papers up, so I don't really want to have to separate them and then put 60 and 30. If I did have 60 and 30 separate, it would be kind of easy. I'd pick 4 from here, 2 from here, but they're all in one bag, and I don't want to fix that. So what I'm going to do is I'm going to pick, and if I run out, like I get too many seniors, I'll just throw the number out and I'll pick something else. And I'll keep going like that until I actually get my sample. So we are going to design a simulation using a table to estimate the probability that it must take 8 or more names to get 4 seniors, 2 juniors. So I'm going to show you how this process works, but we're not actually going to do a ton of trials with this here. That's the basic setup. So I need 8 or more picks is the probability I care about to get 4 seniors, 2 juniors out of this. So I'm not writing out the full thing. Let's just talk labels and what I would need to do. First step is assign labels and get the thing set up. Well, actually, first step is say the probability. What's the probability that in a set of 60 seniors, 30 juniors, it takes 8 or more picks to get this? Just restating that. Next thing you do is get your labels ready to go. So I have 90 people who are in this problem right here. So if I have 90 of them, I got to do 2 digits. I'm going to go, I like starting with 0, 0. That way I don't forget to like rule it out later. So 0, 0 through 59 are going to equal seniors. And then that would make number 60 through 89 juniors. One of the more common errors on this is people doing like the wrong mental math, saying 0 to 60, which would be actually 61 numbers. So just make sure you're careful with that. So if I was writing this out, I would say assign unique number to each student, and I've got my labels right here. So now what I'm going to do, in this problem, do I want repeats? I do not, because that would be picking the same person twice for my committee here. So I would need to make sure that I reject repeats. And I also need to make sure that I reject the numbers 90 through 99. Those don't correspond to an individual. So let me just walk through how that would work and show you a trial right here. My first number is a 19. So if I do this, usually when they give you a table like this, they want you to mark it up and show what you did. Number 19 represents a senior. So I have a senior, then I have 22, another senior, then I have 39, another senior, 50 is another senior. I was supposed to have 4 seniors, so now I'm going to shut it down. Any more seniors that I get, I would want to throw away. 34 is another senior. I think I'm on 34. It's kind of hard to see right here. Yeah, 34 is a senior, so they're out. 5 is a senior, so they're out. 0.05. I have 75. That's a junior. And I have 62, that's a junior. So if I look at my number of trials right there, I had the 4 seniors, I had 2 that I threw away, 5, 6, then I had junior. That was 8 trials right there. So it took me 8, okay? So I would have 8 or more. Oh, that's a trial for that. And then I'd have less than 8, which obviously didn't happen. So then I can either pick up, like just go like this and pick up right there, or I can start on a new line. I'm going to start on a new line just because it's going to be a little less crowded here. You also have to pay attention to repeated numbers. I wasn't super careful about that in the last one because it's so small here, but I don't think I had anything repeats. So I'll show you one more trial. 73. 73 is a junior. P.S. If I were to say I got a 73 in my last trial up here, that's okay if I get 73 in my new trial because it's like a fresh start. Every trial is like a new beginning right here. So if I was going to write that out, I would talk about new trial is like you start fresh. So I have a junior. Then I have a 67. 67 is also a junior. So just like that, I am full of, I'm done with my juniors. Then I have a 64, that's a reject. 71 is reject. 50 is a senior. 99 is a reject. 40 is a senior. 00 is a senior. This is really hard to do with this tiny table here, so sorry if I'm making a mess of this. I don't even know what I have right now. I have 3 seniors, 19 is a senior. So I'd stop right there. Then I count my trials, 1, 2, 3, 4, 5, 6, 7, that's at least 8. So that would be another tally mark right here. If my next time I do it in 5 trials, I put a tally over here, etc. Now, on a quiz, there aren't going to be very many trials because it takes forever to do this. So I'm going to make you do like 5 trials. So say I did 2 trials right here, I would estimate the probability to be 100% because I only did 2 out of 2. Obviously, that's not an accurate probability, but these problems care a lot more about the fact that you can actually understand and carry one of these out rather than that you can get a good, accurate probability. So just go with the number of trials they tell you to, even if it's small. Your quiz will have a problem something like this, where you guys set up a simulation and carry out like a small number of trials. So that is how you conduct a simulation.